Good morning. Very good morning. Okay, I think we were doing the types of matrices, right? The upper triangle matrix and lower triangle matrix. I think this is where we stopped. Yeah, let's just revise the types of matrices and then we shall move on. Now, in types of matrices, we had row matrix, wherein you have only one row. Okay, and there are more number of columns. The row will be only one and number of columns will be more. So that is row matrix. Then next one is column matrix. Here you'll have only one column, but you'll have more number of rows. So that will be your column matrix. Then coming to the square matrix. Square matrix is where you will have the number of rows equal to column. So M is equal to N is the square matrix. The number of rows will be equal to the number of columns. So this is the square matrix. Then coming to diagonal matrix. Diagonal matrix is a square matrix where the principal diagonal values or the principal diagonal numbers, you will have a different numbers here. No matter it is plus or minus, this principal diagonal will be the non-zero numbers. Okay, so diagonal matrix is a square matrix where the principal diagonal starts from left side top to the right side bottom. So this is going to be the principal diagonal, and this will be a non-zero number. It can be plus or minus, but it should not be zero. Apart from principal diagonal, the other numbers are supposed to be zero. So if you see here, 0 and 0 is there. Okay, then coming to identity matrix. Identity matrix is also a square matrix, that is where the number of rows is equal to number of columns, and here again the principal diagonal values will be 1. It will not be uh, any other number other than 1. So this is identity matrix or unit matrix. Now coming to scalar matrix. In scalar matrix also, it is a it is not a square matrix here. Okay, it's just a diagonal matrix. Okay, sorry, diagonal matrix means again it comes back to square matrix only. So in a diagonal matrix, what we will do, we will usually have the principal diagonal as non-zero numbers, correct? So here also you will have a non-zero number, but all the numbers will be same. The principal diagonal numbers all will be same. If you see both the examples here, the numbers are same. Then coming to the zero matrix or null matrix. Now here, any sort of matrix that you take where the elements are zero. Okay, all the elements in this matrix will be zero, and this is denoted by O, capital O. And in matrix, the denotion of the matrix will be in the capital letter, but if at all you are using any elements inside as alphabets, it will be small letter. Then upper triangle matrix and lower triangle matrix. Now upper triangle matrix means the first half of the triangle here will have the numbers. Okay, every square matrix, the first half of the triangle, the upper part of the triangle will be the numbers. It will be the numbers. The second part or the lower part of the triangle, you will have it as 0. So if you see here, this part is 0. Even here also, this triangle is 0. Okay, starting from principal diagonal, the upper part will have the numbers. Now when it comes to lower triangle matrix, the lower part of the matrix will have the numbers. So if you see here, start from the principal diagonal. Okay, start from the principal diagonal and towards the left side. Here also start from the principal diagonal and towards the left side. So this is the lower triangle matrix, where the numbers are there on the lower part of the matrix, and this is upper triangle matrix where the numbers are there on the upper side of the matrix. And apart from this, the rest of the numbers will be 0. So if you see here, the rest of the numbers are 0. Okay, so these were upper triangle and lower triangle matrix. These are the types of matrices. Now moving further, we have something called as multiplication of matrix by a scalar number. Scalar number means if you have one number which has been multiplied with the matrix, how do we multiply that matrix? Okay, so this is very important. Multiplication of matrix is a very important topic which will be asked in the examination for section B, that is going to be 6 marks. Okay, I shall explain you about the format of question paper and everything in the next class. Okay, so that you have a brief idea of how the questions might come, but you will have sub questions for sure. So be have that clear mind, like how you had in test one question, and then you'll have the 1A, 1B, 1C, like that you'll have the sub questions. So one thing I noticed is many of them have not written the correct question number in your test also. If you're not written the correct question number, they will not even correct your answer. So please write the question numbers, section names properly, and then start the exam. Even though you are in hurry, you want to finish the paper, write the question number properly and then write. If you don't write the question number properly, then there is no point in writing the exam only. I hope that is clear to everyone. Okay, so let us understand multiplication of a matrix by a scalar number. Now scalar number is only one number. Okay, so the product of a matrix A, so the matrix is A, by a scalar number P is the matrix whose each element is P times the corresponding element of a matrix. What they're simply trying to say is, if A is a matrix, now if you see A, you have 1, 2, 5 and 6. This is the matrix. Now if you want to find 6A, which is nothing but 6 into this matrix, that is 1, 2, 5 and 6. Now what you have to do here is, you have to multiply 6 with each of the element. That is going to be 6 into 1, 6 into 2, 6 into 5 and 6 into 6. So the value of 6A, I'll just continue here. The value of 6A is going to be 6 1s are 6, 6 2s are 12, 6 5s are 30 and 6 6s are 36. So the value of 6A is going to be this. Okay, so this is how you find the multiplication of a matrix by a scalar number. If you have only one number here, if you have 20, 30, 3, 2, 5, 8, any number that they give here, you are supposed to multiply that number to every element that has been given in that has been present in the matrix. Did you all understand this multiplication of matrix by a scalar number? Okay, good. Now let us move further. Next is transpose of matrix. Now in transpose of matrix, now we'll have to find out the opposite part of the matrix. Transpose means, so transpose of a matrix, the matrix obtained by interchanging the rows and columns. This transpose of a matrix is again a very interesting topic. Understand this. Every problem, maximum of the problem, you will find such questions. Okay, so transpose of a matrix is interchanging the rows and columns, interchanging the rows and columns of a given matrix is called as transpose of a matrix, and it is denoted either by A T, or just write A and put a small 1 above. Okay, that is called transpose. So AT is A transpose. Okay, now here is an example. Let us understand using an example. Thus A is equal to, if A is a matrix of 1 2 3 5, so this is first row, this is second row, this is first column and this is second column. Okay, we are gonna change the first row to the first column and the second row to the second column. Okay, let us do that. So A transpose is equal to, what is the first row? First row is 1 and 2. So I am changing that row into a column. So the column will become 1 and 2. And then if you see, the second row is 3 and 5. So the second column will become 3 and 5. Okay, so this is a transpose. Let us see one more example. So if you have B is a matrix, okay, B is a matrix with 6, 2, 7, 3, 8, 1. This is the matrix. Now let us find the transpose of B, which is nothing but the first row here will become the first column, that is 6 and 2. The second row here will become the second column, that is 7 and 3. The third row here will become the third column, which is 8 and 1. Okay, so this is how you find the transpose, where the rows are converted to columns. So you're just interchanging the rows and columns. So did you all understand what is transpose of a matrix? Anybody has doubt here? Okay, so let us move further. Next, orthogonal matrix. Now orthogonal matrix, let us see what is there. A square matrix A is said to be an orthogonal matrix if into A transpose is equal to I. So if you have a matrix A and if you multiply that with its own transpose, okay, if you change the rows and columns, that will become the transpose, correct? So if you multiply A and A transpose, you are gonna get the identity matrix. Now what is identity matrix? Now here we saw what is the identity matrix. That is nothing but when you have the principal diagonal to be 1, right? So if you multiply, this is one of the property of a matrix. They can ask you to prove this by giving a question. Okay, they'll say if matrix A is equal to, and they'll give a question and they'll ask you to prove A into A transpose is equal to I. Okay, I is nothing but identity matrix, where the principal diagonal will be 1 all the time and rest of the numbers will be 0. So that is orthogonal matrix. Understood orthogonal matrix? Okay, now let us go to the next part, operational properties of matrices. Again, very, very important, because this is what is the actual chapter. Okay. Now let us understand this. Operational properties of matrices. Now operational properties of matrices, first is equality of a matrix. Equality of a matrix means we'll have to see how the matrices will be equal. So two matrices of the same order are said to be equal only when the corresponding elements of both the matrices are equal. I'll read that once again. Two matrices of the same order. First important point to note, same order. Same order means if it is 2 into 3, 2 into 2, the other also should be 2 into 2. If one is 3 into 4, the other also should be 3 into 4. I cannot compare something with 2 into 2 and 3 into 4. This is not possible. Both should be of same order. The dimension of the matrix should be same. Okay, and then are said to be equal only when the corresponding elements, this is the second important point, corresponding elements of both the matrices are equal. Okay, so let's see with an example. So if you see the first one here, we have two matrices, matrix A and matrix B. So in the A matrix, if you see, there is 3. In B also, there is 3 in the same place, 5, 5 in the same place, 6, 6 in the same place, and 8, again 8 in the same place. So if you have a matrix like this, then the matrix A is equal to matrix B. Okay, so this is equality of a matrix. But see the second example here. Now though you have the same numbers in the same place of both matrix X and as well as Y, but still they are not equal. Why is that? Because if you see here, there is -8 in X and there is +8 in Y. So the sign also will matter. When they say the elements should be same in both the matrices, it means along with the sign. Okay, even the sign of the numbers or the elements of the matrix also should be same. Only then they are called as the equal matrix or equality of matrices. If not, they are not equal. Now again, if you see the third example here, all the 3 are equal, all the 3 here are same in both R and S. So you can say R is equal to S. Okay, so this is equality of a matrix. So did you all understand this part? Any doubts in equality of a matrix? Okay, good. Now let us go to the next one, that is equivalent matrices. Now equivalent matrices means, let us see what are equivalent. So this is equality, or you can call as equal matrix. But let us see what is equivalent. Two matrices are said to be equivalent if both are of same order. Okay, here the elements need not be same. So in equality matrix, let me change the color here. Okay, in equality matrix, the elements also were supposed to be same. Correct? Elements also supposed to be same, and order also should be same. But in equivalent matrix, only if the order is same, then you can call it as equivalent. There is a difference between equal matrix and equivalent matrix. Okay, now let's see the example. If A is equal to 2, 3, 4, 5, 6, 7, this is a matrix. Now, can you say me the dimension of this matrix? What is the order of this matrix? How many rows and how many columns are there? 2 into 3. Good, Lakshmi. Lakshmi is fast. What is the order of this matrix? Others, I want everybody to answer. We have 2 rows and we have 3 columns. Correct? Good. 2 rows, 3 columns. So it is called as 2 by 3 matrix. Okay, this is called as 2 by 3 matrix. Good, good, very good. Now, this B matrix, this also is a 2 by 3 matrix. Yes. This is also the matrix B is also a 2 by 3 matrix. So then, since the order is same, see, if you see, the elements are not same. In one you have numbers, in the other you have alphabets. The elements are not same, but the order is same. So when the order is same, you can say them as equivalent matrix. So you will not put equal to, but you will add another line which says equivalent. So A is equivalent to B only on the basis of order of the matrix. Okay, so this is the equivalent matrix. Understood equivalent matrix? Okay, good. Now let us go to the addition and subtraction of matrices. So matrices can be added or subtracted if and only if they are of the same order. First and foremost condition to be understood. So matrices must be equivalent, only then you can do the addition or subtraction. Okay, if you have a 2 by 3 and 4 by 4 matrix, you cannot add them. Okay, it has to be of a same order. If it is 4 by 4, the other one also has to be 4 by 4. Then only you can add or you can subtract the matrix. Okay, then the sum or difference of two m into n order matrices is another m into n order matrix whose each element is the sum or difference of the corresponding elements in the given matrices. So what they are trying to say here is, if you add a 4 into 4 matrix, both the matrices are 4 into 4, you will get another matrix which is again 4 into 4. Okay, which is again 4 into 4, where the elements of this matrix are nothing but the sum or difference of the elements which we have considered here. Okay, this you will understand when we start with the addition and subtraction of matrices. Okay, so let us see how the addition of the matrix is done. Now, if you come here with the addition of the addition of the matrix is done if A and B are two matrices of the same order. Then A plus B is defined as matrix obtained by adding corresponding elements of A and B. So if a matrix is A1, A2, A3, B1, and then A4, A5, A6, there are 6 matrices here. And what is the order of the matrix? There are 2 rows and 3 columns. So 2 into 3 is the order. Now if you see on the other side, that is the matrix B, this also is 2 into 3. Correct? So 2 into 3 and 2 into 3. Now, the new matrix, that is addition A plus B, will be, let me choose a dark color for you to write. Yeah, the A plus B will be A1 plus B1, corresponding elements. In this place, what is the element you have? B1. So I will add A1 plus B1. Then A2 plus B2. So what is the element in this place? Here you have A2, here you have B2. Then here it is A3 plus B3. So I have A3 and then I have B3. Then again A4, B4, A5 plus B5, A6 plus B6. Okay, so this is how we get the values. Now when you add all of these values like a1 plus b1, you'll get a number. Okay, let's say you get C as a number. Okay, so this will be C1, so C2, C3, C4, C5, C6. So this will be your new matrix, that is A plus B. Okay, so that is your addition of a matrix. Did you all understand the concept? Did you all understand the concept of addition? Any doubts in that part? Okay. Now let us understand that addition with a example. Now if C is a matrix of 1, 2, 3, 4 and D is a matrix with 5, 8, 3 and minus 4, first check the order. Now what is the order of C here? What is the order of a matrix? How many rows and how many columns are there? 2 by 2. So C is 2 by 2 and D is also 2 by 2. Very good. C is 2 by 2, D is 2 by 2. Now let us add these two. So C plus D is equal to, how do I add? First corresponding, first value and the corresponding same position value. So I'll have 1 plus 5. Okay, 1 plus 5. And then I'll have 2 plus 8. And then I'll have 3 plus 3. And then again 4 plus minus 4. That will be my calculation. So 1 plus 5, then 2 plus 8, 3 plus 3, 4 minus 4. 4 plus and then minus 4 is there. So plus 4 minus 4 is nullified. So you'll have 0. So the new matrix C plus D is nothing but 5 plus 1 is 6, 2 plus 8 is 10, 3 plus 3 is 6 again, and 4 minus 4 is 0. So this is going to be the addition of a matrix. Clear? Understood? Okay. Next, coming to the subtraction of a matrix. Now, subtraction of a matrix is nothing but if A and B are two matrices, if A and B are two matrices of the same order, again, same order is important, then A minus B, we are calculating A minus B. A minus B is, how did we add A plus B? Every element we added, right? Similarly, here also every element you will minus. Okay, every element you will minus. Now for the same values here, they have taken the example. Now let us first understand how to find A minus B. So if the value is of same order, now what was A and B previously? Now if you see here, A was A1, A2, A3, A4, A5, A6 and B1 to B6. So A minus B is nothing but A1 minus B1, A2 minus B2, A3 minus B3, like this until A6 minus B6. Okay, that corresponding values you will be subtracting. A1 minus B1, A2 minus B2, A3 minus B3, A4 minus B4, A5 minus B5 and A6 minus B6. Corresponding value will be subtracted. Okay, now let us take this example, C and D. Okay, now C was 1. Okay, let me erase this part. Okay, so C was 1, 2, 3, 4. D is 5, 8, 3 and minus 4. Okay, so C minus D is gonna be C minus D is gonna be 1 minus 5. See, if you see 1 and 5 is there, then 2 minus 8, 3 minus 3, and then 4 minus of minus 4. Okay, 3, 4 minus of minus 4. Now, let us find the result. C minus D is a new matrix where 1 minus 5 is minus 4, 2 minus 8 is minus 6, 3 minus 3 is 0, 4 minus of minus 4 is 4 plus 4, so which is going to be 8. Okay, so this is how you find the subtraction of a matrix. So did you all understand the subtraction of a matrix? Yes or no? Everybody understood? Good. Next, there are few properties of a matrix which you are supposed to understand. So let us see the properties. properties of the matrix when it comes to addition. When it comes to addition of a matrix. So there is, these are very similar to your set theory properties. Okay, so matrix addition is commutative, which means if you add A plus B and if you get a matrix, and if you add B plus A and get a matrix, both the values will be same. Okay, so A plus B values of a matrix will be equal to B plus A. Okay, and then matrix addition is associative. Associative means first if you add A plus B, okay, first if you add A plus B, you will get a resultant matrix of A plus B. Now using that matrix, if you add C, you will get the final result. That will be equal to A plus B plus C again, where first you are adding the B plus C matrix. We will solve few problems to understand these properties later. Okay, next, transpose of the sum of two matrices is a sum of their transposes. Now what does it mean? So you will first, you have matrix A, you have matrix B. Okay, you have a matrix A and you have a matrix B. Now you will add both of them. You will add both of them. So that is matrix A and B. Now the values that you get in this matrix is A plus B. Okay, now you will find the transpose of this matrix. Now what is finding transpose? Exchanging the rows into columns is called as transpose of a matrix. Correct? Now when you find the transpose to this matrix, whatever the matrix that you get will be equal to the transpose of the matrices individually. When you add the transpose of A and B here, this and the resultant matrix here will be same. Okay, so that is transpose of sum of two matrices is a sum of their transposes. And then the last property is any matrix plus a null matrix. Null matrix means where all the elements in the matrix are zero. Okay, any matrix plus null matrix is equal to null matrix plus any matrix. This is a normal property of an addition. 0 plus 2 is equal to 2 plus 0 is equal to 2 only, right? Okay, so null matrix is where you have all the elements to be 0. Okay, so that is the complete properties of matrix with respect to addition. So understood till here? Any doubts? No doubts. Good. Now, before we go to the multiplication, we will solve few questions. Okay, and then we will go for the multiplication part. Okay, because multiplication will take a little time for you to understand. So first we will solve few problems and then we will move forward. Okay, so here if you see, present the following data related to marks scored by 3 students in the form of a matrix. So they have given a data here of the 3 students where you have to show them in a matrix. Okay, so let's see the data. Name Ajay, Banu, Chandu, and their marks in accountancy, management, and mathematics. So they've asked us to represent this data. It is very, very simple because the matrix is just the systematic way of representing the data with only numbers. So here they only have given you 3 rows and 3 columns along with an organized number here. So what you have to just do is write it as matrix A is equal to matrix inside the bracket. Just write down the numbers. 80, 45, 65. So this will be accountancy. 80, 45, 65. Then marks in management, 65, 50, 80. Then marks in mathematics, 70, 60, 55. Okay, so this is how you represent a matrix. Understood? Did you all understand this first problem? Okay. Now let us go to the next problem. The next problem is present the following linear equations in the form of matrices. Okay. Now here, how do we represent these numbers in the form of a matrix? Now see the equations. You have 2x plus 5y is equal to 18. Okay, and then 3x plus 4y is equal to 24. So that is the first part of the equation. Now how do we represent this is very simple again. So just leave out all the variables, leave out all the variables, that is x and y, you leave it out there. So what are the numbers that you get? So we'll write a matrix like this, where the coefficients, that is 2, 5, don't put plus minus sign, nothing, just write the numbers. Then 3 here for the second equation, and 6. So this is first row, 2 and 5. Second row is 3 and 6. Now coming to the values or the constants, is equal to, put an equal to and put another, or we are going to write another matrix. That is, for the first row or the first equation, what is the total? It is going to be 18. And for the second one, it is going to be 24. Okay, so when it comes to linear equation, we are supposed to represent them in this format. Understood? Clear with this problem? Okay. Good. Now, let us also do it for this equation where we have three equations, 1, 2, and 3. 3 are there. So in this case, we are going to have 3 rows. Okay. And what are the variables? If you see, you have x, x and x, y, y and y, z, z and z. Okay. We have 3x, 3y and 3z for 3 equations. Now, let us write them. First matrix, first will be 5, 3. Give a little space in between. Don't write 5, 3, 2. It's not 532. This is wrong. Give a space in between. 5 space and then 3 and then a little space and then 2. Then that will be the first. That will be the first row. Okay. Now, after